Section 5. Solving Qualia's problems. Gray speculates, however, that there might indeed be something more to be hoped for from the Penhoff theory. He says, quote, "Both functionalists and physiologists have so far been content to rest with their correlations as indeed brute. Neither have anything at all to say about the nature of qualia. These just are either identified with function or, in Sekhanov's graphic phrase, secreted by the brain. The Penhoff theory, in contrast, does say something about the nature of qualia. They are superposition patterns embedded in fundamental space-time, brackets Planck scale, geometry. To be more accurate, a quale is the particular one among these proto-conscious patterns chosen at any given moment to achieve qualehood, due to orchestrated objective reduction in a microtubule system located in a sufficiently highly organized brain." End quote. Gray comments that this does indeed represent progress, albeit modest, over the other two forms of brute correlation. Quote, "To say something about the nature of qualia is already an advance. It at least recognizes that something needs to be said." End quote. To make this clearer, the advantage is that a particular quale can be characterized by a particular proto-conscious pattern in fundamental space-time. This provides an explanation for the differentiation of qualia across, for example, the different sense modalities. Gray produces an extended practical illustration in an attempt to describe exactly how Penhoff achieves this advance of being able to explain the origin of individual qualae. He imagines that he and another person are looking at a red kite flying in a blue sky. Quote, "Let's also assume that our brains are constructed in a sufficiently similar manner due to evolution that we experience the red kite flying in much the same way. That is, we experience the same qualia." End quote. The Penhoff theory explains this congruence of perception as follows. In my brain, a set of quantum superpositions have self-collapsed inside a set of microtubules, which are in turn inside a set of neurons in the visual system in my brain. These quantum collapses have accessed a chosen state in fundamental space-time. If we both have the same qualia, then these same processes must also have happened in your brain. Quote, "Since the theory states that qualia are embedded in space-time, then if you and I experience the same qualia, our brains must have both accessed the same state in fundamental space-time." End quote. My comment here is that the idea that different types of qualia, shape, color, sound, smell, taste, touch, etc., arise from different states of curvature in space-time is, in essence, quite simple. The big question is rather, how do microtubules in different areas of modality in the brain know which curvatures of space-time to access to get the right qualia. Neither Penrose and Hamerhoff nor Gray provide any clear or at least comprehensible response to this question. I think, however, that two highly speculative answers can be found, one from Gray and one from Penhoff. They both indicate what Gray calls the conformational arrangement of the microtubules. In effect, decide which qualic quantum states get accessed. Gray's explanation as to why microtubules should adopt one shape or another seems to depend on neurophysiology. He starts by simply saying that, quote, specific patterns in space-time give rise to specific qualia. So the qualia accessed in V4 brackets color must differ from those accessed by V5 brackets motion because the corresponding patterns of space-time superposition differ. These patterns depend on the possible types of conformational arrangement of the microtubules that might be superpositioned in each region. And these, in turn, it might be argued, depend on at least the following two factors. First, there are local differences in the neuronal organization in V4 and V5. Second, there are differences in the neuronal connections to V4 and V5 from other regions, end quote. The Penhoff answer identifies connective proteins associated with microtubules. These, it claims, influence or orchestrate the quantum state reduction based on Penrose's particular interpretation of quantum mechanics. Back at his kite flying example, Gray explains that all the relevant quantum qualic events are taking place in two separate brains, yours and mine. Within each brain, the only way to access fundamental space-time is via that particular brain. Gray then revisits Penrose's initial description of the nature of superposition quantum states. Quote, they are multiple curvatures in space-time which exist until self-collapse, whereupon space-time takes up one final state of curvature, end quote. So Gray then continues, quote, when you experience a red kite flying, somehow space-time in your brain adopts a state of curvature that it didn't have before, end quote. And he insists, if both people are experiencing the same qualia, then the microtubules in the appropriate areas of each brain must be accessing the same final state of space-time curvature in order to produce the same qualia in two different individuals. Gray explains how Penhoff's linkage between qualia and curvatures in space-time can provide solutions for some of the traditional problems associated with the concept of qualia. Firstly, the difficulty of the vastness of qualic experience. How can this be encompassed within the physical universe? Gray starts by pointing out that there are roughly 10 to the power of 107 Planck volumes in a human brain, and that each of them can, quote, theoretically be in one of a very large number of states, depending upon such factors as the edge length and the spins of the edges, end quote. If then, according to Penhoff, one quale may be one pattern and another quale a different such pattern, then in principle, the theory allows for the physical production and storage of an infinite number of quale. Gray next looks at the traditional problem of whether quale should be conceived of as single isolated sensory atoms, or whether, for example, very complex multimodal scenes can also be accepted as qualic experiences. Gray says that, according to Penhoff, quote, when self-collapse occurs, only one pattern is chosen, but that pattern is a very complex entity. In this way, the theory attempts to provide a physical basis for both the simplicity of relatively isolated qualia, the sound of a high C played on a flute, and the complexity of a total conscious multimodal scene, end quote. David Rose also questions the traditional idea that qualia, quote, are actually atoms, isolated, individualizable elements of experience, end quote. He asks whether the feeling of wanting to go on holiday is a pure experience. Can it be treated as such independently of other qualia? The traditional ideas of Locke and Hume would deny this. For them, qualia are basic elements which can, through association, be linked together to form complex concepts. But such concepts would not then count as qualia. However, Rose argues that our experiences are generally more gestalt holistic, and that we never experience, or perhaps cannot, either in principle or in practice, experience isolated sensations or raw feelings. Rose concludes that, quote, experience is always a very complex whole and is based on a mass of information coming in all the time, end quote. However, Rose attempts no explanation as to how this mass of incoming information produces qualia, whereas, as Gray described above, Penhoff can provide a physical basis for both isolated qualia, high C played on a flute, and the multi-complex and the complex multimodal scene that Rose is describing here.